concentration. I know you've heard that word before, like how concentrated is a solution, or concentrated orange juice, right? Um, so our learning target is I can analyze and interpret data to describe how changes in the amount of solute or solvent affect the concentration of a solution, and then relate these changes to real world applications in science, health, and the environment. Okay, so the concentration of a solution is the measure of how much solute is dissolved in a particular quantity of solvent. Okay, so as we add solute, the solution becomes more concentrated. Okay, as we add more solvent, the solution becomes less concentrated. Okay. A word that we use for concentrated is called molarity. Okay. Molarity is the ratio between the number of moles of a dissolved substance in a solution and the volume of the solution in liters. Okay. So molarity, big M, is moles of solute divided by liters of solution. And the units are moles per liter. Okay. So here's an example. Find the molarity of 500 milliliters of a solution which contains 60 grams of sodium hydroxide. Okay. So the first thing that we have to do is we have to figure out what is the number of moles of our solute. So we have 60 grams, and we're going to divide that by the molar mass to get the number of moles. Okay, so when we take 60 and divide it by 40, we get 1.5 moles. The overall solution is 500 milliliters. We need to change that into liters. Okay, so 500 liters divided by 1,000 gives us 0.5 liters. And then if we put it into our equation, right, we have 1.5 moles divided by 0.5 liters, and you end up with 3 moles per liter. Or we can say that it's 3.0 molar. Okay? All right. If the solution is already concentrated, and you need to dilute it, dilution is the degree to which a solution has been diluted, right? So dilution is adding solvent, or decreasing the amount of solute. Okay. So again, dilution is the degree to which a solution has been diluted. Okay. When diluting a solution, always add the concentrated solution into the solvent. In other words, back here on this slide, if we wanted to dilute this, we would take our concentrated solution and we would pour that into a beaker, a flask, whatever, that contains solvent. Okay, so we're always adding to solvent as opposed to add the solvent to it. Okay. To determine the amount of solvent to use when diluting a solution, you use the following equation, and M is molarity and V is volume. Okay, so you're going to do the beginning molarity times the beginning volume, and that's going to equal the ending molarity times the ending volume. Okay. All right. Here's an example. How many milliliters of a 2.5 molar sodium hydroxide solution are required to make 525 milliliters of a 0.15 molar sodium hydroxide solution? Okay, so we're starting with 2.5 molar sodium hydroxide. Okay, we don't know what the volume is of that, right? We need to know how much do we need to add to, right? And then we want to make a 0.150 molar solution by diluting it with 525 milliliters. Okay, so in this case, we want to get V by itself, so we're going to divide by 2.5 molar on both sides. And then in the end, when we do this calculation, we'll get 315 milliliters. Okay, all right. So to sum it up, the concentration of a solution is the measure of how much solute is dissolved in a particular quantity of solvent. Molarity is the ratio between moles of a dissolved substance in a solution and the volume of the solution in liters. Dilution is the degree to which a solution has been diluted. And then note, when diluting a solution, always add the concentrated solution to the solvent. Okay.